Hi everyone, this is Billy. Welcome back to my YouTube channel. This is part 2 of the butterfly variable capacitor and the FM crystal radio. In this part, we'll continue on with the DIY process and the testing. If you like this type of DIY video, please support me by clicking like, subscribe and share with your friends. Leave me some comments or questions so I can answer you quickly. Thanks a lot for watching till the end. To make the variable capacitor, you can use this type of copper plate. I have a 0.6mm copper plate, or you can use aluminum plate, which has less Q factor because of the increased resistance. So you got these fixed plates and moving plates from the 3D print files printed. You can place them onto the copper plates. It's better to drill the hole first before you draw the line and cut it out. So to do that, you use a small drill head like 2.5 or 3mm to drill a hole and put everything in place. Use a small screw to fasten it in place. Then you can draw the line and cut it out. This will be much more accurate than just cutting it out and then drill the hole, because your hole may be shifted left and right, and then the pivot point may be misaligned. You need to drill 2 holes for the fixed plates and then fasten that before you draw the line and cut it out. Make sure the pieces are flat by hammering it a few times. If the plates are not flat, then when you move it, it will touch one another and cause a short circuit. Then your VC will fail to work. Here are all the parts we need to assemble the FM crystal radio. You need 4 sets of fixed plates, 3 sets of moving plates, and then all these 3D printed parts. First, slide the ring inside the chassis. Then insert the knob gear and the knob gear filler into the gearbox at the bottom. Then insert the knob into the small hole in the chassis, aligning the notch with that in the knob gear and the knob gear filler. You need to push a little bit or adjust it a little bit to find the exact match that aligns. Once you did that, you see the ring will be rotating smoothly when you turn the knob. Then insert the pivot arms into the hole at the top, matching the notch. Determine what screw size you are going to use, M3 or M4. Then mount the moving plates together, interlace with the nuts. Total, you need 3 moving plates stacked together using the nuts and the screw. Fasten the nuts with your clamp. Make sure it is very tight. Otherwise the contact will be loosened and your Q factor will be much worse. Fasten the screw into the pivot arm. The hole in the pivot arm should be a little bit smaller than the screw so that it is very tight. Insert the whole thing into the chassis. Make sure the small notch aligns with the one in the ring inside the chassis. Make sure you can rotate smoothly, and then fasten the screw at the bottom inside the chassis. Make sure your screw is not too tight, so you can rotate it when you turn the knob. Next, we connect 4 sets of fixed plates together, interlaced with screws and nuts. Use the clamps to apply force so the nuts are fastened very tightly. This will improve the contact and reduce the resistance, increasing the Q factor. Then push it into the hole in the chassis Try to align it to test if the plates are separated when you move the moving plates. You can try to use different size of filler, different thickness, to make sure the fixed plates and the moving plates don't touch one another. Sometimes you'll find the plates need to be bent a little bit so that it won't touch one another. Insert the connecting plates to the two sets of fixed plates and then fasten it using the screws and nuts. Test again to make sure the two sets of plates won't touch one another. Now let's make the coil for the FM crystal radio. Using an AAA battery as a frame, wind 6 turns. You can use the copper wire, or like what I'm doing here, using some silver plated copper wire to increase the Q factor. We will use these 5-pin sockets for our detector. So first we mark pin number 1. Then solder the pins with the threads. We use different colored threads. Pin 1 is brown, pin 2 is orange, and then blue, and then white, and then green, in that order. Insert the threads and the pins one by one into the socket. Make sure the color of the threads follows the order that we just mentioned. Otherwise there will be confusion during soldering. Apply a little bit of AA glue or super glue, but don't put too much, otherwise it may spill out and make the contacts damaged. Push it in, make sure it is dried before you continue with the soldering. Get a 3.5mm stereo headphone jack and solder a 150 pF capacitor across the two terminals. I don't have the 150, so I'm using 200. Then just mount it through the hole in the chassis. Let's take a look at the circuit diagram before we start the soldering. So this circuit is for the diode. We have another circuit for the MOSFET, 3DQ later on. So for the diode, you can use some Scotchy diode. I recommend one SS86 or one SS918. Or if you have similar Scotchy diode, you can use that. It's much better than the germanium diode. In the case of FM crystal radio, you need a very sensitive diode, otherwise you won't hear anything at all for the FM reception. You can see on the left there are two antennas. You can choose either one of them. Sometimes certain stations may do better with one of the two antennas. So you can try both. Or if you have a Yaji antenna, you can connect the two antenna points at the same time to the two terminals of the Yaji antenna. Or if you want to form a dipole, you can have a 1.2 meter telescopic antenna on one of the connection point, and then another connection point you can use a drop wire of similar length, like 1.2 meter. You can try either case whether it will actually improve the signal strength, and at the same time do not create too much noise. Sometimes you can get a louder reception by using a thicker antenna or a longer antenna. However, it will create the noise. So you want to try different length and thickness of your antenna and find the one that fits the station that you're receiving. Tuning into FM radio using a CryStal radio design is a little bit tricky. It's not always the thicker, longer antenna will do the best. So you have to try it out and find out which way it is better. Sometimes you need to switch to different connection point in the coil to find the right tapping point for your antenna as well. Then we'll look at the coil. The coil is created using 1mm copper wire, or you can use some silver plated copper wire that may have a little bit better Q factor and reducing the resistance overall. So you wind 6 turns, and when you solder it, you create a tapping points as shown in the circuit diagram that connects to the antenna connection points or to the diode tapping. There are 2 points that need to connect to the butterfly variable capacitor. The tapping for the diode is 3 turns from the hot end, which is the top of the coil. The tapping point for diodes are different than the MOSFET. MOSFET need a lower resistance, so the tapping point will be 1 turn more from the hot end of the coil. We'll look at that later on when we go to the MOSFET diagram. To filter out the radio frequency from the earbud or headphone, we connect a small capacitor, 150 picofarad. Then you connect the output through the headphone jack to your headphone. I use a CryStal earbud, which I created using a ceramic, or they call it piezoelectric buzzer. I make one out of piezoelectric buzzer and connect it to a ballpoint pen tip, so it will channel to my ear directly through a silicon cushion. It's important that we keep it airtight, so all the small tiny sound energy can fit into the ear. It is important for FM CryStal radio to do it this way because the sound level of the FM CryStal radio is quite tiny, quite small. So you need a super sensitive earbuds, otherwise you won't hear anything. Now let's look at the circuit diagram for the MOSFET 3DQ or 3SK143-Q. The left side of the circuit diagram is pretty much the same. You have the antenna connection points, 2 of them, the coil 6 turns, and the variable capacitor, the butterfly VC. So it's the same. Only the difference is the tapping point. You can see it's 4 turns from the hot end of the coil, or 1 turn above the cold end of the coil, which is the grounding point for this circuit. Then you have extra 1 turn from the grounding point to connect to the second antenna. For the 3DQ, it is a MOSFET, so you have 2 inputs instead of just 1 input like the diode, because there are 2 gates in a MOSFET. Gate 1 we connect it to the circuit ground. Gate 2 we connect it to the hot end of the coil. Then we have an extra input called source S that connects to the tapping point of the coil, 1 turn above the cold end of the coil, or 4 turns down from the hot end of the coil. As I said before, the MOSFET has a lower input resistance, so it needs 1 less turn from the cold end of the coil for that lower resistance. Then the output is fed from the drain, the depot, to the headphone jack. You use the same small capacitor, 150 picofarad, to smooth out the radio frequency and filter it out, so you have the audio frequencies fitting to your ear. If you are using piezoelectric earbud or ceramic earbud, that is a pure capacitance device, you will need to connect an additional 500k ohm resistor to allow the charges to pass on. Otherwise, the ceramic or piezoelectric buzzer will not function well, because it will need to deform first, and then the charges need to be released to reset the diaphragm to the original shape before it can create the next sound in the audio wave. Without that resistor to pass the charges will not be able to pass through the capacitance, and then it will be very bad for the sound. Let's now assemble the circuit. So first we connect the coil to the 2 ends of the fixed plate of the butterfly VC. Then we connect the antenna connection points to the coil. Make sure you fasten all the screws, otherwise the contact will be loose, and you know what, the Q factor will be dropped severely if any of the screws are not fastened enough, not tight enough. Then you result in no reception at all, or very poor reception, or reception with a lot of noise. Okay, then you need to adjust the spacing of the coil. Make sure they won't touch one another, and you have space to do the soldering. Soldering is a very important piece of work for FM crystal radio in particular, because you need to make sure the soldering is short, sharp, and shiny. Otherwise, if you use a thread that is too long, it will increase the capacitance and drop the frequency of the resonance circuit such that you won't be receiving FM at all. You may be receiving short wave or even AM. Let me explain the wiring. So we have a coil that is wound using the AAA cell as the diameter. We got how many turns? 1, 2, 3, 4, 5, 6, 7. 7 turns. But the last turn is for the antenna. So this is an extra turn for the antenna. So actually the coil for resonance circuit has only 6 turns. And here the 6th turn is connected to one end of the butterfly wheel, connects to this white wire, which connects to the pin G2 here, this pin G2 of the MOSFET. Okay, and G1 of the MOSFET, which is this one, which is also highlighted by this mark, which is the brown cable here, the brown wire. Brown wire connects to the cold end of the coil, which is the grounding point, which also connects to the other end of the variable capacitor, the cold end. Okay, so hot end connects to the white wire, cold end connects to the brown wire. So that's the resonance loop. Then we have 2 more points connecting from the coil. This is the cold end, so 1 turn above the cold end. The cold end is also the grounding point, the brown wire. One coil above that we connect to this orange wire, which is this one, connects to the S pole of the MOSFET here, 2nd pin here. The S pole of the MOSFET also has another end that connects to one of the antenna, which is this one, antenna 2. Okay, A2 here. And antenna 1 is this one, connects to this extra turn after the cold end. Okay, so the antenna 1 connects to 1 turn, extra turn of coil after the cold end. Antenna 2 connects to the 2nd turn after the cold end. Okay, the 3rd turn after the cold end connects to this green wire. This green wire also connects to the last pin. This pin is for the diode. So the diode, we have one end connecting to here, which is the green wire. The other end connects to this D. We'll tell you about the D, the string, which is the output. Okay. The reason why we have different turns for 2 types of detector, MOSFET has a lower impedance. It can accept a lower impedance, so it's closer to the cold end of the coil. The diode has a higher impedance, so it's further away from the cold end. So it's the 2 turns away from the cold end. Okay. And the output, which is this blue wire, connects to the drain D of the MOSFET, which is also connects to the other end of the diode, the output of the diode. Right? So when you connect a diode, they will also connect to the blue wire. The blue wire connects to this headphone jack. This is a 2.5 millimeter jack. No, 3.5 millimeter jack. Yeah. And this other end of the jack connects to the brown wire, which is the circuit ground. Okay, so one of the headphone terminal connects to the circuit ground. The other end of the headphone terminal connects to the blue wire, which is the drain, the output of the MOSFET, also the output of the diode. And to filter out the radio frequency, which is a higher radio frequency, We have this around 200 pf. Actually, it's better to have 150 pf or 180 pf, but I don't have those, so I just try 200 pf. It will filter out the high frequency, the radio frequency of FM. So we'll have only the audio frequency coming through this headphone jack. Okay, so that's the whole circuit connection. Left is the drain. Bottom, push it in like that. Okay, this is how you connect the MOSFET. This is a diode, 1SS186, I think. There's a diode symbol here. So this pin, the last pin, and the middle pin, they are for the diode. So one end connect to the D, the output, the other end connect to push in like that. That is how to make the CryStal radio work with a diode as a detector. A MOSFET detector using a 3D printed chassis, and just push it in. It will match one SS192. Diode you line up to the last pin. Next, let's do some testing. I will start with the outdoor testing first using the collapsible or extensible telescopic antenna. Then I will do the indoor testing using my Yagi antenna.
係有啲業績因素啊，同埋有啲所謂微觀嘅一個企業發布方面嚟講咧，市場嘅表現係會比較強一啲嘅。咁另外一方面嚟睇咧，我相信咧就係話部分嘅即係內需股家電有一個所謂唔喺總統嗰度嘅。
只喺5年內出任公職，雖然佢肯定會提出上訴，但上訴程序可能需時幾個月甚至幾年。佢能唔能夠上訴成功，趕及參選2027年總統大選成為未知數。分析認為，現年29歲嘅國民聯盟主席巴爾德拉最有可能接替瑪麗勒龐出選，挑戰馬克龍39歲選上法國總統嘅歷史。但專家質疑佢能夠成功吸引法國年輕選民支持。美元100英鎊對美元財經台天氣報告。本港地區今晚及明日天氣預測大致多雲，今晚及明早天氣寒冷，有一兩陣微雨，市區最低氣溫約12度，新界最低1-2度，日間短暫時間有陽光，最高氣溫約18度，吹和緩北至東北風。展望隨後一兩日同清明節漸轉天晴，日間溫暖同乾。請注意，寒冷天氣警告現正生效。
每8個因疾病而死亡嘅人，就有1個死於二手煙。超過二手煙睇唔到、聞唔到，即使喺室外，二手煙都可以蔓延7米以上。減少二手煙危害，我哋一齊努力。耀才證券祝賀新城財經台業務蒸蒸日上，集咗香港30年嘅耀才證券，一直以逢星期2、3中午12點20分，理財節目時會有林子軒聯同韓國嘅博士創辦人。港台電視1個4點2手煙，應
成嘅二手煙睇唔到、聞唔到，室內吸煙有害物質嘅濃度會急升百倍，亦會黏附喺物件上，透過接觸危害健康。即使喺室內，煙都可以聞。工作去偷手煙與問題發出嘅個聲音。唔記得，唔記得，唔記得。喺度作事，同小朋友一齊歡呼，通常你外不同步參與今年物語。我都係香港。我都係。將我送到我嗰度，嚟禮物。好嘅嘉賓上嚟俾啲聽眾咧知多啲咩叫平等機會啊！咁啊，頭兩天律師啦，請你今日對下屆辦上講嘅都有。好啦，今日喺呢一時間咧，請嚟平機會嘅主席就係林女士 Linda。Hello Linda， 你好。
你好啊。
如果不能夠嘅話，就無論係由平機會提出嚟嘅，即係由個當事人自己提出嘅訴訟，都係啲民事上嘅問題。好啦，咁啊 Linda，請你幫向我哋啲聽眾啦做少少呢個嘅平等嘅教育先啊。係。咁就其實好多時候都係喺我哋會出售咗有呢啲當中有呢啲討論嘅嘛。係咪？其實我哋而家佢哋負責執行嘅4條條例咧，就係包括當佢哋性別歧視條例啦。 自己都唔知。佢唔知自己有呢一個，即係佢有個定型嘅問題。咁好多時我哋會見到呢啲，我哋即係我哋自己見到咧，或者有時候我哋都會做，即係叫做